All right, let's get into some applications of geometry here. And we're going to start with some perimeter and area. And so we're going to start by looking at the side of the house. Here's my house addition that I've been working on and building this part of the house here. And when we're building a house, we get some walls like this big wall right here. It's a big pentagon looking thing here. And we got a bunch of windows in the way. And we got to figure out the area of this siding here, these boards that are getting attached there. And so area is a very useful thing to figure out because these boards will have a certain amount of coverage, all right? So let's try a little simplified problem like this here, all right? So we want to find the area of this wall. So first we can notice we got a pentagon similar to that shape of that side of the house I was just pointing out there. And so we probably don't have an area formula or not familiar with an area formula for a wall like this or pentagon. So we need to break this into some familiar shapes. So let me draw a line. Let me make that a little larger maybe so we can see it better. So let's break this into two shapes. And let's go like this. Here we go. Whoa, let's make that a little wider. Anyways, see that red line there? So we've got to think of this as a rectangle and a triangle, all right? So you've got this rectangle down here and this triangle up here. All right. Now, we're going to have an area formula that we need to look. And in the back of our book, we have some area formulas that you can use there. The area of a triangle is 1/2 base times height. So hopefully something that we remember from some previous classes. The base is this side and the height would be the perpendicular distance from the top of the triangle to the base. All right, so the base has to be one side of the triangle. Great. So, all right. Well, and a rectangle, we're familiar with that. The area of a rectangle is length times width. All right, so we can find the area of this rectangle. And so the question is, do we know the base and the height of this triangle? Well, we know this is 22 feet because that's the same as this guy down here. What's the height, though? Well, right here we're told the pitch of the roof. That's 812. That's a pretty steep roof. My roof over here is a slope of 5/12. But we can find this out now. See this little triangle here? That's a rise and a run. So we need a rise. The rise is the height, and the run would be this distance, which is 1/2 of 22. So this is 11 feet. And so we've got to make a proportion to find the height. 8 is to 12. That's the slope. As the height, which we don't know, this rise is to this run, is to 11. Real close there. All right, and these are in feet here. So we're going to have to cross multiply here. And let's see. So we can solve this up with a little cross multiply. 8 times 11, that's 88 equals 12h divided by 12. Going to get a decimal here, so let's go on over to decimals here. We have 88 divided by 12. So this is just our scientific calculator, desmos.com. Scientific calculator gives us 7.333 feet. Okay, we can leave this in feet for right now. That's fine. 7.333. We'll keep several of those. All right, so we don't need it in feet and inches right now. So this height is 7.33 feet. Okay, that's H. Great. So we can find the area of the triangle, we can find the area of the rectangle. Now, we can do this two ways, all right? I'm going to do it kind of the long way, well, or the two-step way. Let's call it that, the two-step way, and then going to show you kind of the preferred one-step way that we want to move into. All right? So the area of the triangle is going to be 1/2 times 22 times the height, which was 7.3333. Okay? And so we go back over here to our calculator, and we can compute that. We have 1/2 times 22 is the base, times that 7.333. I'm going to put answer, A&S is answer. That brings that down in there. Gives you the last answer. And we get to, there you go, 80.6 repeating. All right. So that's great. 80.66, and we got to round off to 7 at some point. So this is, all right, 80.66, and we got to cut it off and round it off at some point. So then the area of the rectangle, well, that's going to be 22 times 10. So we have area of the rectangle is 22 times 10, which is 220. All right, great. Now we need the total area. Total area, we got to add those up. And so we have 220 plus 80.66. Now this was pretty nice. We didn't really need a calculator for that because 220 plus 80 is 300, right? So 300, yeah, 300.66. And that is feet. Don't forget your units. Okay. So we found the total area there. Directions don't tell us what units. We don't, oh, sorry, this is area. This is areas in square feet. Remember, when we're measuring area, we're measuring how many squares fit in there. So area is square feet. How many little 1x1 squares would it take to fill this whole thing up? That's what area means. So there's a total area. Now, one little suggestion here as we do this, a little better way to do this, I want us to start to get used to this, is taking these two things and writing one formula and going to our calculator once. So we have area equals, we have the triangle, 1/2 times 22 times 7.333, throw another one in there, plus the rectangle, plus 22 times 10. So that includes the triangle and the rectangle part. So this area formula is the total area, and so let's make this total area. So we have one formula for the total area. So as we get into this, we're going to start making our own area formulas, basically. And once we write that in type that in the calculator, or write it as one formula, that is, we got one formula, type in the calculator once, put it all in there at once, and get your answer, 30.663. Okay, really round it off because we stopped there, so it's really 300.667 square feet, as we found out. All right, so we'll get used to that as we go. So we found the area. That was the answer to question 1. All right, so that's question 1. Let's go back up top here and look at question 2. So the question 2 is, how many sheets of plywood now do we need to cover that? So this is the first step to figure out some important building questions. So let's go back over here. To build this house here, underneath we have some plywood. So here's a picture of the house, the plywood underneath that. And so all these plywoods are rectangles or part of rectangles. And so to calculate this wall, we need to know how much area each of those rectangles covers. And that gives us a good approximate. So these are 4x8 sheets. Let's go back here. We can see that we've got some sheets of plywood here. See, I think it ends right there. And then there's another one right there. Okay, these are 4x8 sheets of plywood. And so we need to know how many of those sheets we need to cover this simple house here. Well, first thing we got to do is we got to say, well, what's the area of one sheet of plywood? And the sheet of plywood is 4x8, so it's a rectangle. 4 times 8 is 32 square feet. So the question is, if everything fit perfectly, if we use all of that plywood perfectly, which never happens, we can find the number of sheets by taking the total area and figuring out how much each one can cover. So 300.6667 divided by 32. And this will tell us how many sheets of plywood we need. So we'll go on over here to our calculator again. In fact, I already have that number in my calculator. So I'll just go enter there, answer, divided by 32. And so we need 100, oops, sorry. There we go, 9.39, all right? So we need 9.39 sheets. Now, can we go to the store and buy just 0.39 of a piece of plywood? 9.39 boards or sheets is really the better word. Okay, no, you can't just buy a 0.39 of a sheet. You got to buy the whole sheet of plywood. They're not going to sell you half a sheet. Well, they do have partial sheets, but we're going to buy full sheets is what we normally want. But so we're going to have, we want this to be 10 sheets, okay? We're going to round up. Now notice that's 0.39, and so, but we're still rounding up, okay? 9 sheets would not be enough, but if we have 10 sheets of plywood, then that will be enough there, all right? Great. So now technically we need to order some extras because when you put these pieces of plywood up, it's going to hang over kind of like this house here. You know, there's some sheets. I think there's one that's right about here. And so there was a part of this sheet of plywood that had to be cut off. You might be able to use that somewhere else, maybe, but most likely you're going to lose some plywood. So you just have to have some waste. It happens. All right. So now one more question is this. So how many 12-foot long pieces of siding do we need if it has a 5-inch coverage lap siding? Okay, so what does that mean? Well, these boards here, and it's kind of fuzzy in that picture there now, especially when I zoom in, but so these boards cover a certain amount. So what we're saying here is that this is 5 inches, sorry. The board itself might be bigger, but the coverage, what it shows is 5. So we can imagine that these were strips of wood that are 5 inches by 12 feet, okay? And so one board covers a 5-inch by 12 sheet. So we need to find the area of one board. We're going to do this in a similar way, but the twist is here now that we have inches and feet, okay? So the lap siding, it's called, because it overlaps. All right, so we have the area of one board. Now, you're going to have lots of areas in these kind of formulas here, or these problems. So instead of just writing A equals, it's good to label, kind of like I'm doing in parentheses here. What is this, the area of? Keep your head on straight. So when you go back and look at it and fix things, you know what's going on. So we have 5 inches times 12 feet. It's a rectangle, 12 feet. So we got this long, skinny rectangle for our siding. It's 5 inches by 12 feet. Now, in order to compare this, we need to change this. All right, we need to change the units. And so the area that we've done up here is in square feet. So let's make this into square feet. So 5 inches. Well, 5 inches is less than a whole foot, right? Well, if we do this in fractions, it makes life really easy. 5 inches is what fraction of a foot? Well, hopefully you're thinking it's 5/12. Okay, and so instead of saying it's 5 inches, let's say it's 5/12 of a foot by 12 feet. Okay, now, well, this is just going to cancel. We can go to our calculator and do this, but this is just going to cancel. It's 5 divided by 12 times 12. This is just going to be 5. But we can convince ourselves over here with our calculator. And we can say, all right, we've got 5/12 times 12. Because you notice we just did 5 divided by 12 times 12. Those just counteract each other. It's 5, all right? So, great. So that's going to be 5 feet, all right? 5 square feet, that is. So one board covers 5 square feet. And we know we have 300, so the number of boards or lap siding boards is going to be 300.66, whoops, lost a 0. Okay, divided by 5. So we have our 300, oops. Okay, divided by 5. And so we need 60.132 boards. Again, you can't buy 1.132 boards, so we're going to need to round that up. So this is about, put some squigglies, 60.1 boards, but we're going to round that up to 61 boards because you got to buy a whole number of boards. Okay, it's called discrete numbers. All right, so that's the idea. Okay, so we can find the perimeter. I'm sorry, we can find the area. We didn't actually find the perimeter, but remember, perimeter is the distance around. If we wanted to find the perimeter of this, we would just find all the lengths and add them up. Okay, you would need some Pythagorean theorem for that. But so that's how we find the area. All right, so if you're breaking this into parts, you find the area of one part, and then you can just divide the areas. Now let me add one more version of this question. Sometimes you can do this math here. You know you got 12-foot boards, and you want to figure out how many boards you need. But sometimes you'll go to the hardware store, the lumber yard, and they'll say, all right, how many feet of lumber do you need, or how many feet of siding? So let's change this question and ask that. How many feet of siding, or we say how many linear feet of siding do we need? Okay. All right. So the way we do that is like this. So we're going to say this. We're going to imagine that this siding, sometimes when you buy boards, it comes in all different lengths, especially if you're talking about hardwood or something like that. And so, and when you cut these boards, you know, you cut them into all different sizes and things like that. And so, you know, really, it's not necessarily the number of boards we need. It's how many feet. So if you imagine that these boards came from like this endless giant rectangle. I'm going to put a squiggly. You're going to imagine that it goes on forever there. Okay, we got this huge rectangle, and it's 5 inches by X feet. okay? And we're going to go buy one board. And that one board, we're going to buy it, and then we're going to take that gigantic board and we're going to cut it up into all different size pieces we need. And that we're going to use those pieces to cover the house or the side of the house there. So this is the question that will tell us how many linear feet we need. Okay? Well, to figure this out, we need to say this. So the area of this thing, this long rectangle. Now, really, it's not going to be a rectangle. Really, it's going to be a bunch of pieces that if we stack it on end, if we put them end to end, they'd be different sized boards. But we have got this real long rectangle, all right? And we want to make sure that we have enough area in all those pieces to cover the side of the house. And so the way we do this is we can say the area here is 5 times x, actually it's 5/12 times x square feet. Okay, so it's 5/12 feet, because I'm going to change it to feet, times x. Well, we need that to be equal to the area of the house. So we need 300.6663, it was, right? Equals 5/12 times x. And 5/12, okay, 5/12 gives us 5/12, 0.416 repeating there, all right? So we have 300, we want to divide by 0.41, divide, because that's just 5/12. All right, and so we divide that out. So let's take 300 divided by that, and we'll have our answer. So if we take 300, really 300.6, and we divide that by the 0.416, we get 721.59. All right. So 721.59. So what that tells us is that we would need that many feet, 721.59 feet. And so that would be x, which we want to round that to 722 feet. Okay? So no matter what length of boards we get, if we got 12-foot boards, 16-foot boards, or whatever, 20-foot boards sometimes we get. And we need a total of 722 feet in length. And then that would cover it. Again, we would need to order some extra for the little cutoffs, because when we do this, there'll be little pieces that we'll lose. But 722 feet gives us a good idea of the length we need. Great. Well, so that's how we find the area, the total area. We find the number of boards and the number of lap siding. Okay, so all right, with that we can tackle some problems. So go from there, use some area, find some lengths of boards and pieces that you need there. All right, let's look at some area of a floor plan. Here's a coffee shop. So when you're designing a business, like a coffee shop, you're going to have all different types of flooring. So here we have a coffee shop, and this is a schematic or a blueprint for this coffee shop. Something that an architect or a contractor might draw up. And notice that there's different types of textures here. These are called hatchings. That's the term for it. So these different hatchings, the coloring and the drawings, tells us what kind of material it is. So we got concrete, tile, hardwood, and carpet. All right? So we want to find the area and the perimeter of each section, okay? So actually, let's start out with the total area, all right? I want to show you a couple little techniques for finding the total area and the total perimeter. So area here, notice that this is cut out from a big square. So we got one big square going around here. So you can either find the area of all the pieces on the inside. You know, we could break this up into like, that line seems to go across there. That seems to go across there. You know, I could break this into a few rectangles. There's 1, 2, 3, 4. If I wanted to find the total area, I could find the area of those 4 rectangles and then add them up. But it's going to be a little easier to see, at least, if we find the area of that big red square. I think it's square, at least it's a rectangle, and then subtract off these little pieces. That's going to be a whole lot easier. So let's think about that. All right. So let's figure out the whole rectangle here. If we add up 14 and 16, that's 30 feet, right? And if we add up 18 and 8 over here, that's 26 feet. And if we add up the other sides, it should be the same thing. This is going to be 30 also, and that's going to be 26. So it is a rectangle. All right. So if we take total area, remember for a rectangle is length times width, 30 by 26. Okay. So that's the area of the whole thing. Now we're going to subtract. So this is the whole. Okay. We've got the whole. And we're going to subtract the 3 little rectangles. Well, this guy is a 10 by 6. That's the dimensions. So we're going to have 10 times 6 is the area. This guy is a 6 times 8, or 6 by 8, we say. So we're going to subtract off 6 times 8. And this thing here is an 8 by 14 rectangle. It's 8 on this side, 14 on this side. So we're going to subtract 8 times 14. Okay. Great. And so we have one big rectangle, and we're subtracting off 3 little rectangles. It's all there. We can see it. Now, we're going to work on writing this as one expression. And we can see that everything's there. These are the small rectangles. Okay? Small rectangles. All right. So let's take our calculator here, and we'll just type it in. And we can let the calculator do all the computation. All right? And so we're going to subtract all these little pieces. 10 by 6, which is obviously 60. And if you want to do some of this multiplication in your head, it's good. It's not a bad idea. 6 times 8, you could just put in 48. All right? And 8 times 14. Sometimes, you know, doing some of the simple steps will avoid silly mistakes by typing. All right, that sounds about right. 560 feet there, square feet. Okay, so remember we're talking area here. Area is in square feet. Okay, so let me put my calculator up there for now. So we got 560 square feet. All right. Great. So we got our total area. Yeah, and now our perimeter. So a little technique for the perimeter is this. Right, perimeter. The total perimeter. All right, so let's go see if we can figure out the distance all the way around this thing. So, I'm going to come zoom in here. So imagine that we were going to put like some baseboards. That's the wood around the bottom of a flooring. All right, and so we're going to go, you know, here. See that real red line there? We're going to put these different baseboards around here. Okay. And kind of hard to see that. Let's get a different color. All right, I've put these green lines around here. There's my baseboards that are going around the bottom. Now, perimeter is the distance around a shape. So see this funny looking shape? I could take and I could add up. This is 10 feet plus 6 feet plus that's 14. That's 8 plus 6 plus 18 plus 16 plus 8 plus 14 plus 12. But there's a lot nicer way to do that. Watch this. I just need to add up all these green pieces. So I'm going to take that green piece and slide it over there. I'm going to take that little green piece and come on, green piece, slide it on over there. Now these are supposed to, I didn't draw the lines quite right, but they go the whole way. Okay, this guy's going to go over there. I'm going to move it on up there. Take this one, slide it on up there. Remember, perimeter is just all these green pieces added up. Well, look what I have now. The green pieces added up is going to be just this total square right there. See that thing? So all I got to do is find the perimeter of that square. The perimeter of that square is the same as the perimeter of this funny little squiggly shape here. Okay? And that'll work anytime we have a shape that doesn't concave. If you want to find the perimeter of a shape that looks like this, bump, 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 if it's got a whole bunch of steps like this, doesn't matter as long as it doesn't cave in on itself. So the perimeter of that funny little green shape right there is going to be the same as this rectangle that goes around it. Okay, I kind of missed there, but anyways. Okay, so cool. Well, let's just find the perimeter of the whole thing there. Great. That's all we need to do. So the perimeter of the whole thing is the perimeter of that square or that rectangle there. We found out the rectangle is 30 by 26. So we have the perimeter is going to be, we have two 30s, two sides that are 30. So 2 times 30. And then 2 times, now, kind of jumped the gun here. In the back of your book here, you've got some formulas. 2 times the length plus 2 times the width. So the perimeter is 2 times 30 plus 2 times 26. And that's going to be 60 plus 52 equals 112 feet. So if we want to go all the way around it, we need 112 feet, all right? Cool. All right, well, now let's jump into these smaller pieces. On page 133 in your book, you've got this formula sheet. So we're going to use some formulas off of that. So you might want to look back as you're doing your assignments and things. Look at those formulas. There's that perimeter formula, area of a rectangle, length times width. We're going to use a circle here in a second, area, pi r squared. Circumference, 2 pi r, distance around. Some of these should hopefully be familiar. We're going to use a triangle formula, area is base times height. Perimeter, there's no fancy formula, just add them all up. That's the deal, okay? So we're going to use those, whoops, there. All right, so let's get that out of the way for now. But page 133 be referring to that. So, all right, let's get through some, let's look at some different shapes here. Okay, so let's start with the concrete. Let's go with tile. All right, so we're going to find the different areas. The tile here, that's this area right here. It's a rectangle, and so that there's only one area of tile. That's like the back. I'm guessing that's where like the serving area is, maybe. Okay, so this is where this is our copy shop. So this is probably where the espresso machine and stuff are, and the counter and stuff. So the area is going to be a rectangle. So our area is going to be 5 times 12. All right. So area equals 5 times 12, which is 60 square feet. So we need 60 square feet of tile. All right. That wasn't too hard. Well, let's go for some concrete. Okay, so concrete, that's the hatch or the texture it looks like this. So they got these two shapes. Now, these are trapezoids. Okay, so concrete, we got trapezoids. So how do we find the area of a trapezoid? Let's go to our formula sheet here. And here's our formula. Trapezoid formula looks like this. 1/2 times the height times the two bases. The bases are the parallel sides. All right? So the parallel sides. So we've got to look at this, these parallel sides here. And for this this trapezoid right here, this guy right here, let's start with that. All right. We've got some bases. And so we've got to figure out what this is here. Well, this whole distance is 10. And this little distance down here is 5. So 10. And this guy's 5 here. So this guy has to be 5. All right. That works. Now let's see what's this other base. Well, this is 14. This distance here is the same right there. That measurement is 14. Subtract 5, and we have 9. So, and then this height right here is 12. That's our height. Okay. So we're all ready to go with that area. So the area of that trapezoid is going to be 1/2 times the height, which the height is 12, times 5 plus 9. What that is, by the way, is we're just averaging the 5 and 9 because we're taking 1/2 of 5 plus 9. That's an average. And then multiplying by the height. That's really what's going on. Okay, so that's that one. Now, we've got another trapezoid that we need to add on here, and that's this guy right here. Now, you got to kind of turn your head sideways or turn your computer sideways or whatever if you can. Here, this is the height of that. The height is a distance between the two bases. The base here, okay, let me highlight this. We're now looking at this trapezoid here. That's a trapezoid because one side is slanted. Can you tell there? And so this is 6. We're getting that from this distance over here. This distance is 8. That's given to us. So 6 and 8, those are the two bases. That's our A and our B in that formula. All right, so our second area, our second trapezoid that is concrete, we've got a height of 14, and then we've got 6 plus 8. All right, now we just need our calculator here, which I think I can bring in here. So we can type this in our calculator. We got 1/2 times 12 times 5 plus 9, 1/2 times 14 times 6 plus 8. There it is. Now, by the way, when you're typing things in your calculator, you know, if you can do a few things in your head, it'll be quicker and often more accurate because you'll make mistakes when you type things in here. And by the way, notice I didn't put a times there, but the calculator, your scientific calculator, will understand that that's times. And here, that's times also. So, and if I was typing this in my calculator, I would just do this part in my head. And so 1/2 times 12, well, we know that's 6 times. And 5 plus 9 is 14. Plus, so just kind of did these two, that part of my head, that part of my head. It's going to be quicker than typing. I know 1/2 times 14 is 7, and that is 14. So if you can kind of start the order of operations in your head, you're going to do a lot less typing, and you'll be just as accurate, maybe more accurate, because you'll make fewer typing mistakes. All right? All right, let's shrink this guy down and put that aside for now. So we had 182. All right. Again, we're taking all the parts. We're trying to make one expression. It's going to make things nice and neat. We should see a trapezoid plus a trapezoid. That includes everything. Okay. All right, let's go for this. What is that? The carpet. Let's do this carpet here. Carpet's kind of a funny shape. It's got a circle cut out of it. Okay, but let's go for that next. So we got the carpet. So for this carpet, we've got to break this up into a couple shapes. ignore the circle for a second, all right? But we've got this rectangle, and we've got this trapezoid there. See the trapezoid? All right, so let's find the area of those two, and then we'll deal with the circle. All right. So carpets. I don't know what happened to that. All right, let's see. Carpet. We've got the area of the rectangle. Let's start with the rectangle down here. It's 8 by 16. 8 by 16. Plus, we've got this trapezoid right here. The two bases of the trapezoid are 6 and 16. You see that? 6 and 16. So those are the two bases. Okay, so we have 1/2 times the height of the trapezoid is this guy right here. What is that? Well, let me put my 6 and 16 down. 6 plus 16, that's like the A plus B in the formula, if you look at the formula sheet. Well, this whole thing is 18. This bit is 8, so this bit here must be 10. So we're going to multiply by 10. Now, that is the rectangle plus the trapezoid. We need to subtract the circle. All right? So, what's the radius of the circle? You know what? I think it doesn't tell us, does it? We're not told. Oh, I'm sorry, it does. Yeah, it's hidden in there. See that in there? The diameter. So the diameter is 10 feet. And so the radius here has got to be 5 feet. Okay? That radius is 5 feet. And the area of a circle is pi r squared. We got that in our formula sheet there. Area, pi r squared. I'm going to use that. So we're going to subtract the circle because the carpet is not going to have a circle there. Okay? So minus pi r squared, so pi times 5 squared. And then we're going to go type that all in our calculator. Okay, so typing that in our calculator, we get 159.46. All right. All the pieces there, rectangle plus a trapezoid minus a circle. All right. Now, again, I would have typed this as 5 times 16, save a couple steps, but I want to leave that exact so we can see that, or type it all out so you can see it. Okay. We'll round off to 1 decimal place is good. So, all right, there's our calculation there. Type that over there. Great. So, that's the carpet. Now, the last thing we have here is the hardwood. The hardwood is this circle plus this triangle. Well, we found the area of this circle. This triangle is going to be a little more challenging. But actually, we don't need to go find them individually because we found everything. We found the total area, right? What's our total area? Total area was 560 square feet. We found all the other shapes. We found concrete, check. Tile, check. Carpet, check. We just need the hardwood. So if we subtract each of these boxes from 560, we have what's left, which is hardwood. How's that sound? That triangle is going to be tricky to find, so let's do that. Let's take 560, that's the total area. Oh, this, by the way, is hardwood. So let's take the total area and subtract off each of them. We're going to subtract off this tile, subtract off the concrete, and subtract off, didn't box it, let's box it, the 159.5 carpet. And so, for the grand finale, we get 158.5 square feet. There it is. So that total area, even though we weren't asked for it, came in handy. Now, there is part of the problem that we kind of skipped over here. So notice we were asked for the perimeter of each section also. Well, I'm going to do part of this and leave part of it kind of for you to work on as good practice, all right? We have a rectangle, we can find the perimeter of that here. All right. I'll let you find that one. That one's pretty straightforward there. And then we have this shape. Well, we found out 6, 14, and 8. What is this? Well, to find this, what we're going to need to do is we're going to need some Pythagorean theorem. So we're going to need a right triangle. Let me make that a little bolder. Okay. So we're going to need to make a right triangle out of this. And with this right triangle here, we know that this distance is 6 and this distance is 8. So this guy is 2 and this is 14. And this is C. So we know 2 squared equals, 2 squared plus 14 squared equals C squared. So with our calculator, we can square root both sides and we can find C. And I would recommend just typing it all in like this. Square root of 2 squared plus 14 squared. That's how I type it out on the job site. And on the calculator, just bust that out. We got 14.14. Okay. And we can repeat that for these other ones. Here we've got another right triangle. Pardon my not so straight lines there. That would be a right triangle. We've got 5 and 9. So this guy is 4. And this is 12. So for this one right here, we've got 12 squared plus 4 squared equals C squared. C is the hypotenuse. So we'll get the calculator out to find that. Again, we'll just kind of punch that all in as a square root here. And that gives us 18.4. So this thing here is going to be 18.4 feet. Okay. And what about this other side here? Let's get our calculator out of here. So this one's going to be a little interesting. Let's see if we can get a triangle for that. We're going over, up, and down. And so how far over are we going? Well, we know... What do we know? We know this whole distance is 14. And we know this bit we found out was 4. So this guy's got to be 10. And we know this vertical distance here is 12, and that's 2, so this has got to be 10. So this is going to be 10 squared plus 10 squared equals C squared. A lot of stuff going on here. And so we can find that length with our calculator again. 10 squared plus 10 squared equals C squared. So square root of 10 squared plus 10 squared. 14.14 or 14.1. All right. So this guy here is 14.1. Okay. So now we have everything we need to find the perimeter, all right? So the perimeter of that hardwood is this triangle here. Let's add those up, plus the circumference of the circle. All right, so let's come down here, and we'll get that perimeter. So we have those 3 parts of the triangle plus the circumference of a circle here. Circumference is 2 pi r right there. And so 2 pi r, the radius is 5. So we have 2 pi times 5. And if we add those up, we're going to get 78.01. So that is 78.01 feet. So if we were going to put like a border on there, we'd need 78 feet of border roughly. All right. So that's the hardest one there. All right. So the other ones here, I'm gonna kind of let you work them out. Here's some answers. We get some of these here. For the tile, we get 34 feet here. Okay. For the concrete, if we add all these up here, we're going to get 85.5 feet. And then for the carpet, we have to add up all of, let's see, where'd we go? For the carpet, we've got to add up all of these distances for like a border or a trim around the carpet. We'd also have to add the circumference of the circle. So, because if you were going to put hardwood next to carpet, you would have some kind of trim piece most likely there. And so let's add up all those distances. Here it is here, plus the circumference. Remember, circumference is 2 pi r. Okay, and so 2 times pi times 5, and in the end, we get 93.5 feet of trim. Okay, I think we got all our perimeters. Lots, that's a big problem. So lots going on. You can see lots of challenging math going on to find the perimeter and the area of flooring. All right, so great job. If you're still alive, you're still awake, and you made it through all of that, congratulations. Give yourself a pat on the back. Do a little dance, maybe a little Fortnite dance of your favorite type or whatever. And yeah. Good job. You made it. Congratulations. All right. We'll see you soon. Work hard. Keep it up. All right. Let's look at a welding example. We're going to do some area and length here calculations and see how that affects a welding project. Okay. So here we have a welded steel beam. All right. And before we go too far, I've got to show you my little metal project. Don't do a lot of metal work, but Mr. Lear helped me with this little chimney cover. So, yeah. So, working with metal. Got weight sometimes is important. Not with this stuff. This is sheet metal here. But when you're working with steel, a steel beam, the weight comes into play because this stuff is really heavy. So here we have a plate steel. Or steel plate there. And then we've got these different beams, and each of these beams are different types, and they have different weights. And so we got to figure out how much this weighs because we got to carry it and we got to support it and stuff like that. So let's start off with this this beam right here. This is called a C5x9 beam. Okay, and those numbers mean things. And so let's look at, in the back of your book, you've got a table like this. Okay, this is on page 136 in the back of your book. So C is a channel. See that C? This is a C-type beam. And the 5x9 does mean a little something here. Let me move this out of the way a bit here. So we can see what the 5 and the 9 numbers mean by looking here at this table. So here's our channel. So here's our C5x9. And this in bold tells us what the numbers mean. The first number is D, the dimension, the height. So this is a 5-inch height, but we don't care about that number. This is what we do care about. All right, so we're going to care about this 9. That 9 is the weight. It is 9 pounds per foot. All right, so we know this is 9 pounds per foot here. That's great. Okay, 9 pounds per foot. And let's see, do we know how many feet that is? We sure do. It's 8 feet. So this beam, the weight is 9 pounds per foot. I'll write it as a fraction like this, and we're going to multiply that by 8 feet. Okay, and then if you remember our unit conversion here, the feet cancel because one's on top, one's on bottom, and we just have 9 times 8, and that's 72 pounds. Okay, so that's one beam. All right, and that's its weight. There's another one back there, so we're going to have to double that. Then we have this beam right here. This is an S beam, it's called, even though it looks like the letter I. But this is called an S beam. So S 5 by 10. Let's go look at that. Here's the standard flange, S beam. So S is standard flange. And we had, what do we say? We said a 5 by 10, it says. So 5 by 10. 5 is this D number, which is not going to affect what we're doing. The 10, though, is the weight. So that number is the weight in pounds per foot. So that tells you that this is 10 pounds per foot. So I'll do W for weight. So that's 10 pounds per foot. And we're going by 8 feet. So that's going to be 80 pounds. Okay, the feet are going to cancel. So we have that beam is 80 pounds. The C channel is 72. They're actually both 72, so let's go like this. Let's put an arrow over here too. So we got a couple 72s. We have an 80 pounder, and then we have this top piece. Now those beams were just based off their length. But the weight of this plate, now we got to find out, let's see, actually, I got to move this. It's 3/8, so that's important there. See that? So this is 3/8 inch thick. And so this is showing us that it's that thick. So it's 3/8 thick. So let's go look at our plate steel. And our plate steel that's 3/8 inch thick is going to be 15.3 pounds per square foot. Okay, so we need square feet. Square feet is area, so we got to find the area of this, and that'll give us the weight. Okay, so it's 15.3 pounds per square foot. So we need the area. All right, so we need the area of this. Now we got to watch out because the area here that we want it in pounds per square foot. So this is 38 inches. Well, how many feet is that? Well, if I take 38 and divide it by 12, that's going to give us how many feet? It's not quite 4 feet. It's a little over 3 feet. So let's just leave it as 38/12. So the area is length times width. The length is 8 feet. The width is 38/12. Okay? And if we multiply this up, we have 8 times 38/12 gives us 25.3 repeating. Okay, so 25.3, cut that away. That's our area. So our area is 25.33 pounds. Sorry, no, that's area. So we have 25.33 square feet. And then the weight, well, our weight here is going to be, we're told by looking back at this formula here, it's 15.3 pounds per square feet. The units here are pounds per square feet. The units are important. So we said 15.3 pounds per square foot. So 15.3 pounds per square foot. Okay. And then we're going to multiply that by the 25.33 square feet. And this will cancel the square feet, leaving us with pounds. So all we need is 15.3 times that number we have here. So I'm going to go answer using the Desmos Scientific here. Answer times, what do we say? 15.3. So we got 15.3. 387.6. Okay, so that's 387.6 pounds. All right, so that plate is 300 pounds, over almost 400 pounds. And then we have a couple of these, a couple 72s. We've got an 80, and we've got this 387. So we got to put the total weight. is we have 387.6 plus, now we have two of these 72s, which is going to be 114, and then we've got to add that 80 in there. Okay? All right. And that's going to give us 611.3, and that is pounds. All right, so this is 611 pounds. That's pretty heavy. Can you lift that yourself? Probably not. A couple people, maybe. So a couple people could lift that, but it's a heavy. All right, so that's not going to be too light. So we're going to make sure we can support it with enough strength. Okay, great. Well, one more little example here using area. Okay, so is when we have posts that are in the ground. All right, so let's get a picture for you. So here is a little project I've been working on that I've been telling you about there, and notice that down here we have, this is the deck, and we've got a post, and we've got a cement cylinder here. All right, so we've got some cement in the ground. All right, so there's pressure coming down, the weight of this on all of these, and the cement will kind of redistribute that. Okay, and so it can take a certain amount of pressure. So that's what this problem is all about. All right, so it says this force is commonly measured in pounds per square inch. How many pounds per square inch here is being applied on the surface here? Okay, and that's called PSI. So we want to calculate the force. If we know that it's supporting if we have one of these here is supporting 34,260 pounds. All right. So what's the PSI? What's the pressure per square inch here? All right, the pounds per square inch. Actually, okay. Well, here, what's the area? So we got this is where the weight of the house is sitting. Imagine that the house or the deck or whatever it is sitting up here. Okay. So we got to find the area. The area is 4 by 6. So we have area is length times width, which is 4 times 6, which is 24 square inches. Okay. Now, if we have 34,260 pounds per square inch. Now, a little reminder here, the word per means divide. Okay, so we're doing pounds divided by square inches. So we're talking pounds divided by square inches. Well, how many pounds is it? 34,260. Divided by how many square inches is it? 24. Okay, so this is the rectangle one. So if we divide that out, all right, so we have 34,260 divided by 24. 34,260 divided by 24. That's 142.5 pounds per square inch. 142.5 pounds per square inch. Okay, so it's pushing down with that much pressure. A lot of pressure. Good thing it's concrete. It can probably hold that, all right? Well, what if we take a round diameter that's 16 centimeters here? All right, so we have 16 centimeters. Radius here, watch out, that's diameter, so the radius is 8. So area is pi r squared here, so the area is pi times 8 squared, which is 64 pi, which, if we use our calculator, 64 times pi, so we get 201.06, 201.06 here. So this is 201.06, and now let's find the the pressure, right? Yeah, we're going for pressure, which is pounds per square inch. Okay, well, we know that it was how many pounds again? We know that it was 34,260. So this is 34,260. Divide that by 201.6 or 06. Let's see what we get. 34,260. Oh, you know what? Let's see. Gotta watch out. Have it 170, sorry, 0.3. All right, so we have 170.3, and that is pounds per square inch. Okay, so the big house is setting down on these two pylons, and one of them is holding 170 pounds per square inch. Whoops, per square centimeter actually here. Right, so this is 170.3 pounds per square centimeter. I need a square on there, okay? Can't really compare these because they're different units unless we convert it. So, but there's some area problems. One with some metal and two with some supports for some cement. All right, so use that and see if you can work on those problems in the book. Go apply that math.